Hello and welcome to Chapter 1. Hopefully Chapter R ended well for you and you're all ready for our new chapter, which is on graphs, functions, and models. So when you think graphs, you probably think back to graphing lines in Algebra 1. So that's what we're going to do today, in addition to some other things. So here is a line, or rather the equation for a line. And what I'd like you to do is graph it. You might remember these words. This particular equation is in slope-intercept form. So what does that mean? Hint, hint, slope, intercept form. Pause this video, figure out if you can graph this on your own. Okay, hopefully you've gotten far. If not, that's okay, we're going to review together. So slope, intercept. Which one is going to be more helpful for me to graph first? It turns out the intercept needs to be graphed first because that kind of gives us one point that we can work from. And then our slope will be helpful once we have 1 point. So this is not just any old intercept, right? This is a particular intercept. Is it the x or the y-intercept? It is the y-intercept. If you are fuzzy on what that word means, an intercept is where the line, or the graph in any case, intersects with one of the axes. So wherever the line intersects with the y-axis is known as the y-intercept. Wherever the graph intersects with the x-axis is known as the x-intercept. Certain figures can have more than one intercept, more than one y-intercept, and more than one x, but lines just have one of each, if that. So the y-intercept, it is -1, which means that we make a point right here on the y-axis at -1, and the coordinate for that point is 0, -1. So whenever you've got, this is another characteristic of an intercept, whenever you've got an intercept, if you have a y-intercept, the x-coordinate will be 0. If you have an x-coordinate, or if an x-intercept, the y-coordinate of that intercept will be 0. It's part of the definition. Great, so once we've got our intercept, we can start utilizing our slope. You may remember that slope is rise over run, so that top part is rise. So we're going to make, in order to find our next point, we're going to rise 2 units, and then we're going to run, since it's a positive number, we go to the right 3 units. There we go. Let's do it again. Rise 2, run to the right 3. There we go. All right, so this is enough for like half the line, but if I'm going to make a neat line on this side, I'm going to need some points over here. So let's take a look at what we can do about that. If we know that the slope is 2/3, that is the same as the slope being -2 over -3, right? And so we can think of this slope as directing us 2 down, and the run is -3, so 3 to the left. 2 down, 3 to the left. All right, that should be enough for me to make a neat line. All right. Number 2 is in point slope form, which you may remember also from back in the day. So here's my hint for this one. Point slope form. All right, take a second, pause the video, see if you can recall how to do this yourselves. Okay, so the slope is obvious. It's -3/5, right? What about that point? There is one point that is given to us basically from this format, and that point can be found by looking right here and right here. So point. The x-coordinate of that point comes from this area over here. So we're looking for what x would make this whole parentheses equal to 0. The answer is -4. Okay, so it happens to be the opposite, the number with the opposite sign of whatever number is added or subtracted from the x, but it also can be thought of as what number plus 4 would make this 0. So -4. And then the y can be thought of the same way. What number as y would make this whole left side 0? The answer is +3. So +3 also happens to be the opposite of -3. All right, so we've got our point, we've got our slope. Okay, so your line should look like this. So you start with this point, start on the -3/5 slope, and there we go. All right, so point slope and slope intercept are just 2 formats for the equations of lines. You can have this same line that we just drew here given to you in a slope-intercept format, or you could have it given in a point-slope format, just as you've seen above. So those are just interchangeable formats. You're just manipulating the numbers to put it in a format so that we know how to graph the line more easily. If you ever didn't know how to graph a line, so let's go back to the first one, you could always do this. You could always make a chart of x coordinates, y coordinates. So when I plug in, for example, 3 for x, this would be 2/3 times 3, which is 2. 2 minus 1 is 1. So that makes the y1. So I know that 3, 1 must be on my line. 1, 2, 3, 1. Great, confirmed, that works. All right, back down. There is a third format that we're going to work with for lines called standard form. Standard form comes in the form of a plus b equals c, where c is the constant, a is the x term, and b is the y term. Or actually, it works like this. ax plus by equals c. Okay, so if ax plus by equals c, the one thing you need to know about this is that slope in a standard form is the coefficient, or is the negative coefficient of x over the coefficient of y. All right, so negative a over b. In this case, what's the coefficient of x? Just 1. Coefficient of y, negative 1. So the negative version of that would be 1 over negative 1 is negative 1. Negative negative 1 is positive 1. So slope is 1. All right, the other thing you need is a point. So if you can come up with 1 point, then we're good to go. So in order to graph a line, you need the slope and at least 1 point. So what point can we come up with out of this? We have multiple options, but I think we should make a chart. X, Y, again, or table rather. What will be easy? So let's say if Y was 0, okay. If Y is 0, then what would our x coordinate be? Okay, so y minus x minus 0, that's just the same as x. And then what's left on this side is 7. So 7, 0 is one of our points. Okay, we could have done this a different way. We could have said, all right, let's figure out what y is when x is 0. So this would be 0 minus y equals 7. This would be y equals, we got to divide each side, if that goes away, we got to divide each side by negative 1, and we get negative 7. Each of these things will work. All right, and now that we've got points, we can use our slope, which was 1, okay, to check and make sure this works. So let's look at this point, because this was the original one we did, 7, 0. Right, so if we go 1, 1, 1, 1, 1, 1, that will work. And we could also use an alternative. Now I'd like you to try graphing this line on your own. It's in something that looks like standard form but isn't quite there, so that is your hint. Go ahead and pause the video. Here's the standard form. Ooh, that's a B, yep. Here's the standard form formula. I'd like you to pause the video and see if you can figure out what the slope is and how to make a chart in order to find enough points to graph this line. Good luck. Okay, here's what I've got. I found that the slope, well, firstly, I had to switch this order in order to actually get this in standard form. The x term needs to be before the y term if it's going to be standard. All right, so once it was standard, I could do my thing where I had slope as the negative coefficient of x, which is a, over the positive coefficient of b. So this is negative 3/2 is the slope. Found my point, plugged in 0 for x, and then solved for y, got 0, 6, and was able to use that slope to find more points. We are good. So now we come to this. This doesn't quite look like it's going to be the graph of a line. Maybe it will be. Maybe I'm just not familiar with anything with an x squared yet. But if we're really not sure what kind of figure this is going to be, and this isn't in a form that looks like a line format, like slope-intercept or anything like that, then let's just make a chart. You'll get used to these charts. And let's plug in some points for x and see what it gives us for y. All right, when you're doing these charts, it's always good practice to do some negative numbers and some positive numbers. And if you don't know where to start, you can always start with 0. So I'm putting this in the middle of my chart. If I plug in 0 for x, then y is going to be the same thing as 0 squared, which is 0. if I plug in 1 for x, y is going to be 1 squared, which is 1. Okay, so plotting these points. So far, it looks like it might be a line. Interesting. Let's keep going. All right, so if we plug in 2 for x, y is 2 squared, which is 4. Okay, that deviates from the pattern. So if we plug in 3 for x, y would be 3 squared, which is 9. Okay, so we've got 2, 4, 3, 9. This is looking a little bit curvy. I'm going to pause this and do the other side. Okay, and this is interesting. When I do this for negative numbers, say that x is -1. So y is -1 quantity squared. That means that y ends up being +1. Right, if I do this for -2, I'm going to get y equals -2 quantity squared, which is +4. I bet you can guess what the next one is. So if x is -3, y is -3 squared, which is +9. Okay, it looks like it's mirroring the other points, mirroring the positive versions of each of those x coordinates. And it makes this lovely shape that we call a parabola. So I believe you have dealt with parabolas before. Get used to it, because we're going to do this a lot from now on. For the time being, the best way we have to graph a parabola is to make these types of charts. Use your sense of intuition about what the parabola will look like to decide which x coordinates to try and which x coordinates to plug in order to find the y coordinate. So for example, I wouldn't be starting with 50 because not only is it off my graph, but I know it's going to get me a really huge y, and that will also be off my graph. So yeah, starting with 0 is usually a safe bet, and then you can go up and down based on your predictions about what the parabola will look like. So let's try it for this one. This parabola equation looks a little bit more complicated, but I can tell you it's still a parabola because I've got x and something else with it, but squared, and I've got y not squared. So anything that has either x squared and y not squared, or y squared and x not squared, is going to be of a parabola shape, or parabolic shape. That's how we say that, parabolic. So I'm going to pause this, and I want you to make this chart. Do your best to find points that are going to help you graph this accurately. Good luck. Okay, turns out the points I chose are not helpful in the least. I chose 0 to go in for x, oops, xy. So if we plug 0 in for x, we end up with 0 plus 3 is 3 squared plus 5. That is going to be 14. So I have the point 0, 14. I put it up there because I can kind of reach it, but you're going to need some different points in order to actually get a feel for what this parabola looks like. All right, so we have already got the 0, 14. I went ahead and did this on my own, so you can pause the video and do these if you'd like. So -1, 9 is going to be on our parabola, -2, 6, -3, 5, -4, 6. And if I want to see more of it, I'll just keep plugging and chugging. So if x is to be -5, then that means I would have -2 quantity squared, which is +4, plus 5, 9. So -5, 9 is another one. All right, so now I can see what this parabola really looks like. And the last part of our day is going to be on how to use your graphing calculator and all this. So get out your graphing calculator and type in these numbers just as you see them. This is a y equals equation, slope-intercept form. So type in the right side of the equation. It's already got y equals. Then you're going to want to press zoom 6. Now you could press graph, but that's going to give you the graph settings that you used last time you graphed something, so they might be a little wacky. So you want to make it standard. So press zoom. Number 6 is standard. That'll show you from y equals -10 to +10, and x equals -10 to +10 of the line. Good. It matches the picture, so however, this last one, it's not in slope-intercept form, so we're going to have a really hard time plotting it on the y equals screen because it's not in y equals format. So I want you to pause the video, manipulate these numbers, change this equation so that it's the same value, but it's y equals something. This right here is good enough form for us to put in our y equals screen. All right, when I do, I press zoom 6, just like last time. However, nothing pops up. That's weird. All that means is that we have a wrong window or a not helpful window being shown. We're only seeing this much of the y-axis and this much of the x-axis. So what you need to do is go to Window and determine how to change this x-min, x max, y min, y max, those are the only four you're changing, in order to see this view. So that is your homework. Good luck.